All right, so section 7.4 is called Properties of Logarithms. What we want to do now is get a feel for how could we use these to solve. And we have to do that in baby steps. You know, we've got 7.4, 7.5, and 7.6 in this chapter to go through. So section 7.4, Properties of Logarithms. We start with our objective. We're going to use the properties of logarithms, but it's like, well, how do you do that? I mean, we're still trying to get used to logarithms. How to use logarithms? Well, because they're inverses of exponents, they follow the same rules that we use for exponents. Let me give you, for instance, if I ask you to do x to the third times x to the fourth, do you remember what we do to get that answer? Yeah, we don't really multiply, right? We add. So if you want to multiply exponents, you actually have to add. So it works the same with logarithms. If you see multiplication of logarithms, you have to add instead. That's how it works. How about something like this, x to the 8th over x to the 3rd? How did we deal with that? We subtracted. So division is subtraction. And then we had this situation where we'd have x to the 3rd and we'd have to square it. Do you remember what we did with those powers? What did we do if it was x to the 3rd and we had to square it? That was multiplication. So to raise a power to a power, we have to multiply. So we have to use those same rules with logarithms that we used when we did powers. I'm going to go through this getting ready and then we'll touch back on that again. Because this getting ready shows us that logarithms are really cool in the way that they work with things to undo powers. So what I'm going to do, I know some of you don't have calculators, is just have you follow along with this. It says write a positive number on a piece of paper. I'm not even going to do that. I'm going to put it in my calculator. I'll just pick a number, 23. Nothing special about it. It's a number. It's 23. Positive number. Key this number into your calculator and press enter. Did that. Then perform the steps shown here. Press enter after each line. Do you recognize the number that results? Well, let's see. So now I'm supposed to take the log, which is the common logarithm of that 23. So that's going to be, log is just to the left of the 7 button. So I'm going to put answer in there because that's what they want me to do, but I could punch in log of 23. And I get that mess. Oh my goodness, I don't recognize that. Then it says take 2 times that. Okay, times 2. Now add 4, right? Add 4. Now I want to take 10 and raise it to that as a power. So 10 to the, and now I'll have to use the second negative button to get the answer up there. And then it says take the square root of that, right? Square root, that answer. And then divide it by 100. Do we recognize that number? That's what I started with, right? So what they're saying is this process of using logarithms and the adding of the 4 and all of the steps that they have us do there actually is undoing all of the math that we see above it. So right now would be a really bad time for me to explain to you why all of that works, because we haven't covered the material yet. But what they want us to do is just know, hey, this works. When we're done with this section, maybe we'll have an idea of why all of this works, and we can come back to it and talk about why it works the way it does. But for now, when we start off today, here's what I need you to remember. I need you to remember when we dealt with powers before, if we needed to multiply x to the 3rd times x to the 4th, we actually had to add. Multiplication in exponential language is going to be addition. If we wanted to divide, we had to subtract. And those kind of make sense because they're both inverses of each other. If you want to undo multiplication, you divide. If you want to undo addition, you subtract. And then the other one was if we want to raise a power to a power. So I'm just going to put power. We had to multiply. All of those things that we did with exponents, we have to do with logarithms. Because remember, logarithms undo powers, so they have to have the same set of rules for the way that they work. That's the only way they can be inverses of each other. So our essential understanding says that logarithms, I always forget I have to start by hitting that little plus. Logarithms and exponents have corresponding properties. The properties that work for exponents have to work for logarithms. They absolutely do. So it's been a long time since we did these. It may feel like this is the first time you've learned it. It's not. You know, we did do this before with powers. So down here it says, for any positive numbers m, n, and b, where b is not equal to 1, we're not going to have a base of 1. We talked about that before the break, that 1 to any power is just 1, so that's kind of silly. These properties apply. Now look at this one. It says logarithm base b of m times n. So I started thinking, okay, multiplication in power language, we had to add. And that's what this says. It's the logarithm base b of m plus the logarithm base b of n. That's called the product property. So if we need to multiply in logarithm language, that means we're going to have to add, because that was exponential language. If we want to multiply, we have to add. This one says the logarithm base b of m divided by n. So I started thinking, okay, if I had x to the 8th over x to the 3rd, I have to subtract. Same thing here. Logarithm base b of m minus logarithm base b of n. That's called the quotient property, because really it is division. We've got m divided by n there. Then we have the logarithm base b of m to the n. Okay. So logarithms are an inverse of powers. We're raising a power to a power. X to the 3rd squared was x to the 6th because I had to multiply. So notice how this little n that was up here for a power, because I want to multiply by it, has gone out in front. In fact, let me do this. So when we raise something to a power, it becomes multiplication. And that's called the power property. They're the same properties that we had when we were dealing with our exponentials. They're the exact same. It's just getting used to the fact that, okay, logarithms, I have to do the same stuff. I have to follow that same pattern that I had when I was dealing with exponentials. Everybody set with that page? All right. So next up, we just jump to this. We're supposed to simplify them. So it says, what is each expression written as a single logarithm? Now, what this is doing is it's forcing us to look at this and say, hey, I can use this forwards and backwards. If I see that I'm supposed to multiply, I can add. If I see that they have me adding, then I know that's multiplication. So we use this process forwards and backwards to get everything that we need. So let's see. What is each expression written as a single logarithm? I see subtraction there. When did we have to subtract? Division. So really, we could write this as logarithm base 432 divided by 2. Now it says, what is each expression written as a single logarithm? In most books, this is called condensing. They'll ask us to condense. And that's because what we're doing is we're taking something that has 2 logarithms and we're putting it together into one. We're condensing it down. We're making it smaller. Wait a minute. We know what 32 divided by 2 is. What is it? It's 16. In fact, we can go even farther if we snail shell this in our head. 4 to the something power is 16. What's the something? 2. The answer to this problem is 2. And I know, like I said, it's been a while here. If you're forgetting the whole snail shell, what we did before was we said if we want to know what this is, we do equals x, and then we say 4 to the x equals 16, and that makes it understandable. You look at that and go, wait a minute, that's 2. I know that's 2. 4 squared is 16. So the answer to this is 2. So by condensing it, this is pretty cool, by the way. Look at this. This says 2. Well, like I said before, math is kind of its own secret code language. This is 2, just as much as this is 2. They're equivalent to each other. They're the same. All right, let's look at B. Hey, there's numbers out in front. Where on earth did those come from? Suddenly now they're multiplying out in the front. So when did we have to multiply when we were doing exponential stuff? Yeah, when we had to raise them to a power. So we better put them back up as powers. So this one needs to go back up here to the x, and this one needs to go back up here to the y. So this will be the logarithm base 2 of x to the 6th plus the logarithm base 2 of y to the 5th. Good, we put the powers back. Do we just have one logarithm statement? That means we're not done. So we've got another step to take here. Somehow we have to undo that addition. When did we have to add with exponentials? When we were multiplying. So we're supposed to multiply these two things together. So that'll be logarithm base 2 of x to the 6th, y to the 5th. Now, this time we have x's and y's. We don't have a number, so we can't go any farther. If it's a number, we should always try and figure out what it is. And notice my hand just naturally goes in that snail shell loop as I try to figure that out. But I can't know what those are until somebody tells me what x is and what y is. So that's as done as it can be. But notice how it looked much more difficult up here. Now it's condensed. Now it's in just one logarithm statement. All right, down here. Let's see what we can do. What is each expression written as a single logarithm? Take a look at A. Do we have any numbers out in front? So we don't have to put the powers back up. But it does have addition. What was addition for again? Multiplication. So we're supposed to take 5x times 3x. Well, that'd be 15x squared. Now it has a number part, but it also has a variable part. So this one we can't simplify it down to one number again. Whenever there's variables, there's going to be variables in this. Brett?
So they always have the same base.
Yes, they have to be the same base. Brett brings up a good point. If this was logarithm base 3 and this was logarithm base 4, we couldn't do anything more with this problem. The bases have to be the same so that we could put those together. Yeah, Brett.
And I have calculated.
Why do you need a calculator? I hope not. I hope we can talk through these. All right. Take a look at B. This just seems to be taking up a lot of space today. All righty, I see a 2 in the front. Where did that 2 come from? A power. Notice I'm not going to do anything else with it yet. I'm just putting that power back up. Hey, do we know what 6 squared is? What is it? It's 36. Okay, it's not condensed yet because we still have subtraction. What is subtraction for? Division. So logarithm base 4 of 36 divided by 9. Oh, we know that. 36 divided by 9? Four. Oh, that's got to be an easier number. Snail shell it. 4 to the something is 4. What do you get? It's 1. Very cool. Says 1. That's just awesome to me. That big mess right up there really just says 1. That's all it says. So, what we just did was condensing. We took the bigger ones that had more than one logarithm in them. It said logarithm base 4 in one, logarithm base 4 in the other, and we put them together. That's called condensing. But we also have some times when we have them condensed and we need to break them apart. Because there's something that we see where we go, wait a minute, if I broke that off of there, that would be pretty nice. So we can expand these by just using those properties backwards. And that's the next piece we need to do. So this one says, what is each logarithm expanded? What that means is I have to tear apart the 4, the x, and the y into other things. So let's see. First off, 4x over y, that's division. So division in logarithm language, what do? We subtract. So that'll be the logarithm of 4x minus the logarithm of y. And notice I had to put another log in there because now we're expanding this and we're making it bigger. Okay, now the 4 and the x aren't separated yet. That's multiplication. In logarithm language, we don't multiply. What do? We add. There it is. Logarithm of 4 plus logarithm of x minus logarithm of y. Now, question for you. There's no base on that one, is there? Do you remember before break what we said the base is? If it's not there, Brett, you remember?
Yep.
It is 10, because we have a base 10 number system. So if there's no base, it's a 10. We don't need it because they didn't use it, but if we did, we could slap a 10 in there for any of those bases. All right, take a look at B. I see division again. Division in logarithm language is what? Subtraction. There's a power there. We're not supposed to leave powers. Where are these powers supposed to go? Out in front, yeah, because powers become multiplication. And yeah, now I see why Brett was asking for the calculator, because most people aren't going to remember the powers of 9, right? 9 squared is 81, so if I didn't have a calculator, I'd say, well, wait a minute, maybe 81 times 9, maybe that's something nice. Well, look at that. That's going to be a 3. 9 to the third equals 729. So it'll be 4 logarithm base 9 of x minus 3. And it is expanded. We broke it apart. We found what we needed to. All right, now, I think I checked your packet and we still had the old problem here. Your homework gets more involved than the problems they had in your packet. So let's go ahead and change A to logarithm base 3 of 48x squared over 31. So that you have something that's a little more, well, closer to what your homework is doing. So you can either put an x through the one they gave you or something. But let's make A logarithm base 3. That's going to be hard to see that 3. 48x squared over 31. Right? There, that's better. Bigger. Big one is better. All right, you ready? What do you see? Division? Good way to go. Let's separate that division out of there first. Now, the next step is really important. Here's why. If we bring that 2 out in front, we're saying both of these things are something squared. Are both of these things something squared? So we have to separate them first. So multiplication is what in logarithm language? So logarithm base 3 of 48 plus logarithm base 3 of x squared minus logarithm base 3 of 31. Now we can deal with the 2. Because it's only this term right here that has the 2, not everything. So logarithm base 3 of 48 plus 2 logarithm base 3 of x minus logarithm base 3 of 31. And now 2 things we should check. Is 3 to some power, some nice power I should say, 48? 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. No, we can't simplify this one into something nice. How about logarithm base 3 of 31? You raise 3 to some really nice power and get 31. So this is done. That's all we can do with this one. But we always should check at the end, do the numbers work out nice? All right. How about this one? Oh my gosh, isn't that teeny in your tablet? Okay, but it's darker than it is up here. That's awful to see. Logarithm base 3 of 9x to the 5th. All right, tell me what you want to do. Addition. Pull them apart. Bring the 5 out in front of both of them. Nope. Just this one has the 5th power. Oops, forgot to put the 5 down there after I said I was going to do that. Anything else we can do with this one? If it is, it's the first one. Snail shell. 3 to the something is 9. Something nice? 2. So notice how it's the one that has the number that we try. 3 to the something is 9. Oh yeah, I know that. That's 2. So 2 plus 5 logarithm base 3 of x. So condensing and expanding is what we were doing. And I think this is probably a good spot because, yeah, you're all kind of looking like it's a little shocking being back in school here after all of these days off. So our objective, we were using the properties of logarithms. So 43210, man, how you feel about it? Where do you think you're at? So some of you are saying to yourself, I might have to make a little cheat sheet to write down multiply means add, divide means subtract, all that good stuff. Well, let me ask you that then. In logarithm language, if we're supposed to multiply, what do we do with them? We add. Multiplication is addition. If in logarithm language we need to divide, what do? We subtract. If we have to raise something to a power in logarithm language, what do? Multiply. Bring that number out in front and multiply by it. All right, little practice at this. I know you guys are going to have it. So there we go. Now, what else should we talk about? Tomorrow is ACTs. And since this is a junior class, there is not going to be an additional lesson or additional homework or anything like that beyond this. The assignment you see up there is the one, do this tonight, then you won't have to think about any of that tomorrow when you're taking the ACT test. And then we'll just get back at 7-4 on Thursday. Mr. Duskin's going to be here for me again on Thursday. My daughter has another college visit, but then I'll be back on Friday.